Morning all. Welcome to the lecture 8 of module 1 in database management system. The topics we are going to discuss today is classifications of DBMS and database languages. In the last session we have discussed about the architecture of the DBMS. So this classification of DBMS is actually the continuation of the architecture. Okay. So let us go into the details of the classification of DBMS. That is the first topic, classification of DBMS. DBMS can be classified based on the following criteria. Okay, so we can classify the DBMS based on these 6 criteria. What are those? The first one is based on the data model. DBMS classification based on data model. Data model we have already learned about data model. What are the data models? Relational model, hierarchical model, network model, object model. Okay, all those data models we have already learned. So DBMS can be classified based on those data models. Okay. Next one is based on the number of users. So DBMS will be used by many, maybe it will be a single user or a multiple user. Based on these two criteria we can classify DBMS. Okay. Next is based on the database distribution. So in DBMS, the database will be placed at different locations. In centralized DBMS, the database will be stored at a single site or a single system. But in distributed system, this database will be available in different sites or different servers. Okay, so all those concepts are called a database distribution. So based on these database distribution, we can classify DBMS. Okay, based on cost. Based on cost means the database there will be different types of database available in the system in the market. Okay, some of will be open source and some of will be based on the payment basis. Okay, so there are free versions as well as paid versions also. Okay, based on that criteria also we can classify DBMS. Next is based on the access path. So what do you mean by access path? Access path is a method to retrieve the data from a record, retrieve the record from a table or a database. Okay, so that is called access path. So access path is a method to retrieve a particular record or a particular data from a table or a relation or a database. Okay, so based on the access path, so there can be different access path. There are different access paths used for accessing such records or accessing such data from the database. So based on that concept also we can classify DBMS. Next is based on the purpose. For what purpose we are using a database? For example, for airline reservation, some of may be using a database for the airline reservation, or some of them will be using a database for managing their financial auditing documents or financial things. Okay, so some of them will be using database for managing their products in their in their supermarket. Okay, so based on those purpose also we can classify database. Okay, now we can see all these things in detail. So first one, as I told, it is based on the data model. So data models, there are different types of data models. We have already seen relational, object, hierarchical, network. We have already seen. So relational DBMS means the database is stored in the form of tables. Tables means data will be stored in the form of rows and columns. Okay, so such database is called a relational database. Okay, so this relational database is a commonly used database system that is prevailed today. Okay, so it is a commonly used commercial DBMS. It is a relational DBMS. Okay, next one is object DBMS. So object DBMS, from the name itself, object means that this is actually implemented using the concept of object oriented. Okay, object oriented concepts. Object oriented concepts means in relational DBMS we have seen that there are different tables or different relations. Okay, instead of relations, this object DBMS will be having different objects. For example, there will be a student object, there will be a department object, there will be a admission object. Okay, so different tables, in the sense different objects. Okay, so this is called object DBMS. So this is implemented using object oriented concepts. Clear? So the object data model has been implemented in some commercial system using object-oriented concepts. Clear? Next one is hierarchical. Hierarchical we have already seen. It is in the form of a tree structure. Okay, tree structure, and each parent can have multiple children, and each child can have only a single parent. Okay, so that is called a hierarchical DBMS. Okay, that is also a data model based on this hierarchical DBMS. Okay, this is also a data model, hierarchical DBMS. Okay, so many legacy applications still legacy means earlier applications. Okay, older applications still run on database system based on their hierarchical data model. Okay, so some older versions of the database are still running in this hierarchical hierarchical data models. Okay, so example of such hierarchical DBMS is IMS. Okay, this is a very important example of a hierarchical database management system is IMS. Okay, so please make a note of it. IMS is the best example for a hierarchical DBMS. Next is network DBMS. So network DBMS is some more relaxed version of the hierarchical one. Okay, it is also a tree structure, but the difference is that each child can have multiple parents. Okay, so that is the difference. The network data model was used by many vendors and by products like IDMS, DMS 1100. Okay, these are the examples of network DBMS. Okay, we are not explaining about the network DBMS or hierarchical DBMS. Here just we are giving the examples of such databases. Okay, so IMS is the example for a hierarchical DBMS. IDMS and DMS 100, DMS 1100 is an example for the network DBMS. Okay, so based on the data models, we can classify a database management system. Okay, so these are the classifications: relational, object, hierarchical, and network DBMS. Okay. Now, second one is based on the number of users. Okay, so I said that there are different types of users in a database management system. Okay, the classifications are based on single user and multi-user. So single user system supports only one user at a time and are mostly used with the PCs. Single user means a particular database can be accessed only by a single user at a particular time. That is called a single user system. But multi-user is not like that. Multiple users can access the database at the same time. Okay, so multi-user system which include majority of the DBMS to support concurrent multiple users. Okay, multiple users can access the database at the same time. This is called a multi-user. Okay. Next, third one is based on database distribution. How a database exists, that is explained here. Database distribution. So first one is centralized DBMS. So centralized DBMS means the database will be placed in a single computer. Okay, what do you mean by centralized system? Centralized system means there will be a centralized database. There will be a centralized database and many clients will be attached to that. Okay, that is called a centralized DBMS. So the centralized DBMS means that the database will be residing in the central DBMS. Okay, and the clients will be accessing this. Client will be accessing this database through this centralized system. Okay, that is called a centralized DBMS. Centralized DBMS can support multiple users, but the DBMS and the database reside totally at the single computer site. Okay, so DBMS and the DBMS and the database reside at a single computer. That means that the system or the main server is server is existing in a single system, and this server system is connected with the different clients. Okay, so this server will be having all the databases and the database management system softwares. Okay, that is called a centralized DBMS. But in the case of distributed DBMS, it is not like that. In distributed DBMS can have actual database and DBMS software distributed over many sites. Okay, each system can act as a separate DBMS. So suppose there are 5 systems. Okay, 5 systems are there. So these 5 systems can have different databases as well as different database management system softwares. Okay, so the data, that is what it is saying, that database will be distributed in all these systems, all these 5 systems, not in a single system. Okay, that is called a distributed DBMS. Can have actual database and the DBMS software distributed over many sites or many systems. Okay, connected by. So how these systems are connected, how these sites are connected? They are connected using computer network. Okay, so these are the main concepts of database distribution: centralized DBMS and distributed DBMS. Centralized means the database will be placed in a single computer and many clients can access those computer. Okay, clear? The database as well as the DBMS, which is available in a single system. But here the database and the DBMS will be actually present in different systems, which is distributed in different systems or different sites, and these sites are connected through computer network. Okay, so this distributed DBMS is further classified into homogeneous and heterogeneous DBMS. So homogeneous means that homogeneous DBMS use the same DBMS software at all the site. Homogeneous, we have already told that there are different systems. Okay, we are having different computer sites, different systems. 3 systems are have. All these systems are having separate database, separate DB. All these systems are having separate DB. Okay, this is called a distributed DBMS. Clear? Now homogeneous DBMS, homogeneous distributed DBMS means that it uses the same DBMS software at all the sites. Okay, so database is split on all the system, but all are having the same software. Okay, it is all are having the same software. Here all are having the same software. Software means the database management system. Okay, all are having the same database management system software. But in the case of heterogeneous, what is the case in heterogeneous distributed database management system? It uses different DBMS software at each site. So each site will be having different softwares. So first site will be having software 1, second site will be having software 2, and the third site will be having using the software version 3. Okay, this is called a heterogeneous distributed database management system. Okay, distributed heterogeneous, why it is written double D, heterogeneous distributed database management system. That is why it is given as DBMS. Okay, distributed database management system. So this homogeneous and heterogeneous is actually the subclassification of this distributed database management system. Okay, so this is the concept. Now the third classification is based on the cost. So database management systems are actually freely available. Freely open source softwares are there, open source systems are there. Examples of such system is MySQL and PostgreSQL. These are the open source DBMS products. Okay, so these open sourced DBMS products like MySQL, PostgreSQL, that are supported by third-party vendors with additional services. Okay, so these are provided by some third-party vendors. Third-party vendors mean third-party companies will be providing such systems. So, so such systems are having some additional services. Okay, now another type is there, that is based on the payment. Okay, so relational database, RDBMS means relational database management system products. Okay, so these are relational DBMS products. Relational DBMS products are available as free examination for 30 days copy version, which means that 30 days trial version of the RDBMS softwares are available. Okay, 30-day trial version of are DBMS softwares are available in the market. Okay, so after the 30 days trial, they have to purchase the full version. Okay, now another version is the personal versions are there. So personal versions will be costing around $100. Okay, and these personal versions will be having a fair amount of functionality. Okay, mostly all the functionalities are available in this personal versions. Okay, so based on this cost, okay, based on our budget, we can choose the appropriate database management system. Okay, that is what they are saying. Okay, open source is there, paid versions are also there. Okay, even trial versions are also there, but the functionalities will be minimal. Okay, so these are based on cost, the database management system classification based on cost. Okay, the fifth one is based on access path. So access path, I have already told how we can access a particular data easily from a database. That is done using an access path. Okay, so access path are alternative ways for retrieving specific record or specific data from a relation or a table. Okay, for that we are using this access path. Okay, so DBMS can be classified based on the types of access path. Okay, for options for storing files. Clear? So based on this available access path, we can classify the database management system. Okay, so the well-known access path that we are using is the inverted file structure. Okay, inverted file structure is a part of the index structure. Indexing we have already discussed. Okay, we have already come across the term called indexing. Okay, index is a access path mechanism. So in that indexing mechanism, there is a technique called inverted file structure. These are the commonly well-known or commonly used access path mechanism used today. Okay, so one well-known family of DBMS is based on the inverted file structure. Okay, so inverted file structure is the access method that is commonly used. Okay, so we'll be discussing about this access path or the indexing techniques in the forthcoming modules. Okay, the sixth one is based on the sixth as well as the last classification is based on the purpose. So DBMS is based on different purposes. Okay, sometimes it may be used for a general purpose or some special purpose. Okay, so as a user we are using the database for general purpose, but there are some specialized operations or specialized users. They will be using the database for some specialized purposes. Okay, let us see in detail. DBMS can be a general purpose or a special purpose. When the performance is primary consideration, a special purpose DBMS can be designed and built for a specific application. Okay, if we want a proper if we want to get a specified or we want to get a better performance, in that case we have to create our own specialized database management system. Okay, for example, in banks and all, they are having their own specified database management systems. Okay, they are not having a general purpose systems. They are having their own database. They are having their own databases and they are having their own softwares. Okay, so when performance is the primary consideration, we will be using the special purpose DBMS. Can be designed and built for a specific application. Now another thing is that the application that is created for a specialized purpose cannot be used for other applications without major changes. For example, we have created a database management system software for a bank, for example SBI Bank. That software cannot be used in a retail chain, or they cannot be used in a manufacturing company producing a car. There they are using different database system. Okay, so they have to modify the entire database system in order to comply with their system. Okay, so that is why it is saying that such a system cannot be, that is a special purpose DBMS cannot be used for other applications without major changes. Okay. Now they are given some examples. Many airline reservation and telephone directory systems are using special purpose DBMS. Okay, airline systems, banks, telephone directory system, they are using their own specialized DBMS. Okay, these fall into the category of online transaction processing systems. Okay, so all these databases are actually is dealing with the online system, online transaction. So such a database is called such a type of database is coming under the category called online transaction processing system. Okay, OLTP. Okay, so these are the classification of DBMS based on purpose. Okay, so these are the 6 points from which says the how we can classify a DBMS based on data model, based on number of users, based on the database distribution, based on the cost, access path and purpose. Okay, hope you are clear. The next topic we are going to learn is the database languages. Okay, how we can control a database or how we can control a system using a particular language. Okay, so database languages is being classified into 3 categories. So database language, from the word itself we can say that database language is an interface that is used to communicate with the database. Okay, in order to suppose we are having a student database. Okay, we have stored all the details of for college students in a particular database. Okay, now we need the data of a particular student studying in S4CS. How can we retrieve it? We can retrieve only using a database language, or we can retrieve only using an intermediary. Okay, only an intermediate language can perform certain operation and retrieve those information. For that purpose we are using the database languages. Okay, now these database languages can be used for 3 purposes. First, database language can be used for creating a database or altering the structure of the database or providing some constraints. Okay, simply we can say that, in simple term we can say that we can create a database schema using a particular database language. So such type of language is called a data definition language. Okay, so this data definition language is not dealing with the data. It is actually dealing with the database schema or the database structure. Database structure means how a database must be present, how the database must be viewed, or how the database must be available. In that database, what all attributes must be there. For example, a student database, in what all attributes must be there. So roll number must be there, name must be there, marks must be there. What are the data types of the each attribute? Roll number must be integer, name must be in character, marks must be in float. Okay, so all those things are actually dealt in the data definition language. Suppose I have created a database called student, which contains 3 attributes: serial number, name and marks. Roll number, name and marks. Suppose I want to add one more field, date of birth. So in that case I am actually modifying the structure of the database. That can also be done using this data definition language. Okay, so which means that I am not modifying the data stored in the database. I am just modifying the structure, or I am providing certain constraints or integrity rules. I am going to give certain rules in the structure of the system or the database. Okay, so such language is called data definition language. Next is called data manipulation language. So data manipulation language is actually dealt with the modification of data. If you want to update the data of a particular student, if you want to update the mark of a particular student, which means that we are actually modifying the actual data in the table. That is done using a database data manipulation language, DML. Okay, clear? Now next one, which is the data control language. So data control language is actually used to control the access to the data in the database. Suppose we want to save a database, save the data that is stored in the database. That can be done using a data control logic. Or suppose we have lost the information already stored in the database. In that case, we have to recover those data from the backup. In that cases, we can roll back the system, roll back the data. So such operations are actually performed in the data control logic. Okay, so we can see all these things in detail. So data definition language. A database schema can be specified by a special language called a data definition language. Okay, so database schema. Okay, database schema means the structure of the database. How many attributes are there? What are the data types? Any constraint must be provided. All those things. What are the keys? All those things can be provided here. Database schema can be specified by using which language? Data definition language. Okay, so this highlighted point is the main thing. DDL is a set of, DDL means data definition language, is a set of commands to create, modify and delete a database structure but not data. Okay, so DDL contains a set of commands, okay, or set of instructions to create. We can create a database, we can modify a database, even if we can delete the database. Okay, also we can delete the database structure. Okay, database structure but not the data. Okay, it is not touching the data, it is just dealing with the structure of the database. Okay, we can create a new database, we can modify a new database, or even we can delete the database, but we are not actually we are not concerned with the data. Okay, so this is called a DDL. When data values are stored in the database, it must satisfy certain consistency constraints. DDL provides facility to specify such constraints. Okay, what else a DDL can do? DDL can provide certain constraints also. Consistency constraints can also be provided. What do you mean by constraints on the database? Suppose we can say that we are creating a database with the three student table with the three attributes: serial number, name, marks. Okay, so we can say, we can give a constraint such that the serial number must not be empty. Okay, it must not be empty. That is a constraint. Or else we can say that the serial number field is the primary key. What do you mean by primary key? Primary key means it is a key that is used to identify a particular relation uniquely. Suppose that means that roll number 1 in S4 CSE, roll number 1 means only one person will be there. Roll number 2 means only a single person will be there. Okay, so using a roll number, we can uniquely identify a particular record. For that you can use that is called a primary key. So we can set the serial number as a primary key. That is another constraint. Okay, so such constraints can be provided using this data definition language. Okay, so this is done while we create a table, create a relation. While doing the creation process itself, we will be giving certain constraints. Okay, clear? So these are the constraints. Now next point, they have given the example of such constraints: domain constraints, integrity constraints, authorization. Okay, so domain constraints. So domain constraint means we can give that this domain must not be kept empty, serial number must not be empty. That is a domain constraint. Integrity constraint means we can give some integrity rules such that a primary key is an integrity rule. This can be set as a primary key. Primary key means this can be used to access a particular record uniquely. Authorization means how many people will be allowing to access these three data for a particular user only. We are having a huge database. We are giving authorization to view only authorization to view the data based on their privilege. For example, a student is not allowed to view the phone numbers of other students or the details of other students. They can view the name as well as marks as well as the roll number of their friends, but they cannot view the details, their address, their phone numbers. Nothing can be viewed. Okay, so only the authorized person can access those data. Okay, so authorization can also be provided using this data definition languages. Okay, so who is performing this data definition? Who is performing this data definition? That is the next point that we are going to discuss. Who is performing all those things? A database administrator and a database designer is actually doing all these concepts, creating a database, modifying, providing consistency constraints, and so on. Okay, so it is used by the database DBA, database administrator, and by the database designer to define both the conceptual and internal schema. What do you mean by conceptual schema and internal schema? Conceptual schema means they are actually discussing the structure of the database, all those things, the data types, their constraints, and so on. Internal schema means how we can store this database, in which location we can store, what index structure we can use. So all those things are actually seen in the internal schema. Internal structure, how we can store the data, in which location we can store, whether we have the specified space, we have allotted space is there for storing the database. All those things can be explained here. Okay, so these are done by a DBA and a database designer. What is DBA? Database administrator. Okay, now next language is data manipulation language, DML. Okay, DML, data manipulation language. So these are actually dealing with the data, not the structure of the database. These languages are actually dealing with the data stored in the database. Okay, a DML is a language that enable user to access or manipulate data. Okay, we can access the data stored in the database, or we can manipulate the data stored in the database. Okay, through DML, what are the operations we can perform? We can insert a new data in the database. Student, we have created a student database. We have not inserted any data. We can insert those data using insert command. Suppose we want to update a particular student. Okay, at the beginning of the admission, only 55 students were there. Okay, after 1 month, 2 more students admitted. In that case, we can update that database. Or if one student have left, okay, we can remove the database, remove the data. Okay, so that is called to modify the data already stored in the database. We can modify the data already stored. Okay, we can suppose we want to if a phone number of a particular student is changed, in that case we can update it. Okay, so already stored data can be modified. That is called modifying. Okay, we can delete data, we can remove data. If a student has left the college, we can remove that student. Okay, retrieve the information. If we want a specific information, we can retrieve those data. For example, we want to retrieve the name of the student who has scored high marks in the first series. Okay, that is a query. Using a query, we can retrieve that information. Okay, so so these are the operations we can perform using DML. We can insert data, modify data, delete data, and retrieve information. Okay, so how we can write a DML language or DML code? In order to retrieve the information or in order to insert a data, we have to write certain codes or certain commands. Okay, so how we can provide those commands? We can provide those commands using two techniques. First one is procedural DML and non-procedural DML. Okay, what is procedural DML? The procedural DML is the same concept is the concept that we are actually using in writing a program. While writing a C program, we will be using a procedural method. Line by line, we will be writing the codes. Okay, so that is called procedural DML. But in non-procedural, this is quite easier method. Instead of writing big codes, we can write a single query. Okay, using this query, we can very well retrieve the information, or very well we can do the operations. Okay, so let us see in detail about the procedural DML and the non-procedural DML. So we can see what is procedural DML. So procedural DML is also called low level. Okay, low level or procedural DML. So this procedural DML will specify what things. It specify the data, what data is needed and how to get those data. Okay, two things a user has to specify. The first one is what data the user needs, and the second one is how to get those data. Okay, for example, I want to get the details of the student who have scored highest mark in the series 1. Okay, so that is the data, what data I have to need, what data I need, that is the data I need. Okay, and how to get those data, where that data is available, how can we retrieve those data, that must be also present, that must be also written in the code. So how we are writing this code? These codes are written in the form of procedures or methods. Okay, or procedure programming we have already seen. In C language is a best example for a procedure language. Okay, so procedure language, how we are writing those codes, how we are writing the program in the form of procedures or functions or methods. Okay, so it requires writing procedures or methods to specify what data is needed. Okay, so we will be writing methods to specify what data is needed. Okay, so this low level or procedural DML is actually embedded in general purpose programming languages. So this concept or this programming, this low level procedural DML is actually integrated along with the programming language. We can use this programming language to write the procedural DML. Okay, now next one is high level or non-procedural DML. Okay, this is a high level mode of DML concept, and it is much easier. It is not complex as the procedural one. Okay, here a user needs to specify only what data he needs. Okay, what data he needs. He does not need to specify how to get those data. Okay, that is the difference. So here the user needs to specify what data he needs without specifying how to get those data. But in procedural code, we have to specify both things. What all things? What data we need and how to get those data. But here we don't require to write the code for how to specify how to get the data. Okay, so instead of writing this procedural code, we'll be writing small codes. The small codes or small programs are called query. Okay, so a query is a statement requesting to retrieve the information. Okay, so if we want to retrieve certain information or if we want to store certain information, we'll be writing queries or statements. Okay, so in relational database management system, okay, the commands that we are giving to a system for certain operations are called queries. Okay, so in DBMS we will not say that we are writing program. We only say that we will be writing queries. Okay, so query is a statement requesting to retrieve the informations. Okay, now high level DML such as SQL can specify and retrieve many records in a single DML statements. Okay, we can have high DML. In high level DMLs, in order to retrieve any complex data, to retrieve many records, for retrieving many records or complex records, we can write only a single DML statements. Okay, using a single DML statements, we can retrieve many records at the same time in a single DML. Okay, for example, in nested queries and all, we'll be applying the nested queries and all. Using nested queries, we can retrieve the information easily. Okay, that is what they are saying that in DMLs, high level DMLs such as SQL, they can specify and retrieve many records in a single DML statement. Okay, so therefore, these DML statements or DML languages are also called a set at a time or a set oriented DMLs. Okay, such DMLs, such a high level DMLs are also called set at a time or set oriented DMLs. Okay, so this is the explanation for a procedural as well as non-procedural DML. Okay, so this procedural as well as non-procedural DML is actually a subcategory of a DML. Clear? So we have covered data definition language, data manipulation language, and the third one is data control language. Okay, I have already said that data control language is actually used to control the access to the data and to the database. Okay, we want to control the data access, how we are going to access the data. Okay, if we have stored the data must be stored, the data must be saved in the database permanently. Okay, so such things are actually done by this data control language. Okay, so DCL statements are grouped with the DML statements. So DCL statements are actually, we are not specifying the DCL statement separately. It is a part of DML statement itself. Okay, DCML statements are actually combined along with the DCL statements. Okay, so such statements are commit. So commit is an example for a DCL statement. Commit means we can save the work done or save the data we have already stored. Okay, so while creating a database, and we have certain we have completed a task on the database. So after completion of the task, we used to perform commit operation. So commit operation, after performing the commit operation, the whatever data we have done will be saved in the database permanently. Okay, next one is rollback. Rollback means if we want to, if any data loss happens, we can restore the data. We can restore the data using a rollback mechanism. Okay, that is called rollbacking. In case of any data loss or in case of any failure, we can roll back the system using a we can restore the database using this rollback mechanism. Okay, so restore database in the original since the last commit is called a rollback. Okay, so if any database loss occurs, it will be restored back to the last saved point. That is called, that is it is written like this, since the last commit. Okay, since the last saved point, this will be restored. Okay, so these are the three different database languages. It is very important concept. You have to learn it thoroughly, because based on these three concepts, actually we are implementing the our SQL commands. Okay, in the next module we'll be writing the SQL commands. For writing the SQL commands, we need to know these concepts. So this is actually the introduction to the SQL. Okay, so for writing this SQL, you have to write, we have to know this concept: data definition language, manipulation language, and data control language. Okay, thank you.